Today I want to talk about conditional probability problems using tree diagrams. So this was actually a problem on your handout. You might not have taken it home over break. So I am going on the calendar for today's where you found this video. I'm also going to put a handout that has this problem as well as some homework problems. So you might want to, if you have printer capability, you might want to print this out so you'd have it while you're watching the video. So here's this problem. The incidence rate for a particular type of cancer in a certain population is 1 out of 1,000. The presence of this cancer cannot be detected by visual inspection, but a diagnostic test is available. So what this is saying is that if you picked a person at random from the population, the chance that they would have this disease would be 0.0001, or 1 out of 1,000. Anyway, this diagnostic test is highly likely to give a correct result. Well, that's good. In particular, it correctly detects the presence of the disease in 98% of all cases. So what that means is if you have the disease, then 98% of the time you'll get a positive test result. And if you don't have, if you have the disease, 2% of the time you'll get a negative result, even though you have the disease. And the test also correctly detects the absence of the disease in 99% of all cases, so that's a good thing. So that means if you don't have the disease, you'll get a negative test result 99% of the time, which means if you don't have the disease, there's still a 1% chance that you'll have a positive test result. So here's the question. An individual is randomly selected from the population, given the diagnostic test, and the test result is positive. In light of this information, how likely is it that the individual has the disease? So that's what we want to investigate. So how worried should you be if you are given this diagnostic test and you get a positive result? How worried should you be that you actually have this disease? When you do a problem of this type, the first thing that you have to do is start with a probability. So it's going to be this one right here. We know that there's a probability, the probability that you have the disease is 0.00, oops, too many zeros, 0.001. Now what I'm going to do is called a tree diagram, and this is going to help us find the probability and answer this question. So I'm going to start with this idea that there's a 0.001 chance that you have the disease, which means there's a 0.999 chance that you don't have. And when you're reading one of these types of problems, you have to be able to decide what it is that you are talking about for your first branch. So you have to be able to identify that first branch. Sometimes it's at the beginning of the problem, sometimes it's at the end of the problem. Usually you'd find it in one of those two places. So now for the rest of this, if you have the disease, remember we're told that it correctly detects the presence of the disease in 98% of all cases. So if you have the disease, then there's a 0.98 chance that you're going to test positive, which means that there's a 0.02 chance that you test negative. If you don't have the disease, remember we were told there's a 99% chance that you test negative, because that would be a correct test result, and that would leave a 0.01 chance that you test positive. Now what you're going to do next is you're going to take these branches and you're going to actually multiply those probabilities. So I'm going to multiply 0.0. Oh, this calculator is going to be a problem here. Okay, so have the disease and test positive, so we're going to multiply those two things, and so I get 0.00098, and the next one down, 0.001 times 0.02, we got 0.00005, so be careful with how you interpret these. 2 times 10 to the negative 5 places to the left. The next one is 0.98901, and the last one, which is not on there, but I did, and you can verify, is 0.00999. Now take just a minute and pause the video and add these up. Remember, this is not part of it. That was not part of our tree diagram. But 0.00098, add these 4 different probabilities up and see what you get. Okay, you should have gotten 1. I wonder if you really paused the video. If you just knew, I would tell you the answer anyway. So anyway, that will always be the case because you have to fall into one of these 4 possibilities. So this means that you have the disease and you test positive. This means you have the disease and you test negative. This means you don't have the disease and you test negative. And this means you don't have the disease and you test positive. Okay? So next the question is, an individually is randomly selected from the population, given the diagnostic test, and the test result is positive. In light of this information, how likely is it that the individual has the disease? Now notice that I did a whole lot of work before I even answered the question. Now we're ready to answer the question. Now I want you to notice that this is a conditional probability. We're given that the test result is positive, and we're asked how likely is it that they have the disease. So we're being asked to find this probability. The probability that you have the disease given that you test positive. That's what we're trying to find out. Now, as a reminder, our definition of conditional probability is the probability of A given B equals the probability of A intersect B over the probability of B. And this is a definition of conditional probability. Okay, so we're going to apply that right here. So I need have the disease given they test positive. So I need to find the probability that they have disease and test positive divided by the probability that they test positive. Okay, because the A is like having the disease and the B is like testing positive. The given part is what goes in the denominator. So this is what I have, and I have these numbers right here on my tree diagram. The probability that they have the disease and they test positive is this one right here. So 0.00098 is what goes in the numerator. The probability that they test positive. Now there's 2 different ways you can test positive. You can have it and test positive. You might not have it and test positive. Notice that these are disjoint events because you can't both have the disease and not have the disease at the same time. So since they're disjoint events, if I want to know the probability that the test is positive, I can add these 2 things together. So I end up with, in the denominator, I'm going to have 0.00098 plus 0.00999. So those are the 2 different ways that you can test positive. Now if you take this and now divide it out, 0.00098 divided by the sum, and remember if you are using the divide by key and not using a fraction key, don't forget to put parentheses there. But go ahead and do that and you come up with an answer, 0.0893. So remember what this means. In this situation, if a person tested positive, the chance that they actually have the disease is less than 10%, 0.0893, which is why when you have medical tests done, you always want to have a second opinion or have a second test done. You never want to just go with one result. Think about it. If you were told that the test was positive and you had the disease and you had maybe you were undergoing some kind of intensive chemotherapy treatment or radiation, and you might not even have the disease. So you definitely would want to get a second opinion and or have a second test done. So anyway, this kind of gives you an example of what to do for this type of problem. So these are rather lengthy, I know, because I had to type them in. These are from your textbook, so they are on page 366 if you happen to take your textbook home with you. Otherwise, like I said, you'll want to copy or print off or access on my webpage. You can see these problems and take a look at them. Let me just give you a hint on this. Remember I said to get started with your tree diagram, you're going to have to look at, find that probability. It's usually either at the beginning of the problem or at the end. And right here, you're going to find it. It's going to involve this 12% of the drivers that they think have been drinking. On this one, about lie detectors, they tell you that as you go through, well, I'll leave for you guys to kind of come up with those. But again, you'll need to try and find that. Well, I'll tell you right here. They believe that 95% of the job applicants are trustworthy, so that's going to kind of be your kickoff point there. And here you have, this one will be interesting because you actually are going to have 3 branches to start off with on your tree because you have 3 people, Al, Betty, and Chuck, that all work at Dan's Diner. So anyway, you can go ahead and work on those 3 problems. That is your assignment, and hope to see you on Thursday.